Welcome back to another video. In this video, we'll be using the IMDB dataset of 50k movie reviews available on Kaggle to create a sentiment classification machine learning model. If you want to know how to implement a neural network model on this dataset, make sure to check out my next video on this topic. All the links mentioned in this video can be found in the description box below. If you're new to this channel and like my content, please hit the like button and smash the subscribe button and turn on bell notification so that you don't miss any updates. Stay tuned. So first, let's import the required libraries. So, we are importing Pandas for basic data operations. We are importing Matplotlib, Cbonds, and Plotly to generate various visualizations. We are importing style to set the style for our plots, and here we are using the style ggplot. We are importing RE to use a regex function. We are importing portStemmer to perform stemming. We are importing stop words to remove all the stop words, and then we are setting the stop words as English. And then we are importing word cloud to plot the word cloud. And then we are importing TF-IDF vectorizer to vectorize the documents. And finally, we are importing train test split to perform train test split on our data. Now that we have imported the libraries, let's read the data from the CSV file. And then let's use the head function to see the data. Now let's use the shape attribute to see the size of the dataset. As we can see, there are 50,000 entries. Now let's get some more details about the dataset using the info method. So now we have an idea of the number of rows and columns. Now let's use a count plot to view the count of the different sentiments in our data. And let's add a title to it. And as we can see, the dataset is highly balanced. Now let's print the first 5 reviews along with their sentiments. So there we have the first 5 reviews in our dataset along with their sentiments. Now let's find the number of words in each review. To do this, let's define a function. So this basically takes in the text reviews, splits the review text and then returns a count of words in it. Now let's apply it to the data frame. Now let's see it using the head function. Now we have a count with the number of words in the review. Now let's use this word count to see the distribution of the positive and negative reviews. So similarly, let's visualize the length of positive and negative reviews. Before moving on to text processing, let's do one more thing on our data, and that is to convert the target column into numerical format. So let's replace the positive values with 1 and negative values with 0. Now let's see the modified data frame. Let's now proceed to process the text data. Data processing is done to make the data into a usable format. There are different steps involved to convert the data into a usable format. You can do them individually on the text data, or what I'm going to do here is to create a function that does all of my text processing, and then I'm going to pass my data into it. So if you've been following my videos for a while, you must have been familiar with this step. So let's define a text processing function. So here we are performing lowercase conversion. Here we are removing the break tags. Here we are removing the URLs. And here we are removing the hashtags and the @ symbol. And here we are removing the punctuations. And then we are removing the stop words. And finally we are returning the process data. Now let's apply this preprocessing function on the text data. Now let's check for duplicates in our data. We can perform that by using the duplicate function. So let's take account of all the duplicate entries. As we can see, there are a lot of duplicate entries in our data. So let's remove the duplicate reviews. Now there's one more thing left to do, and that is to perform stemming on the data. Here for this project, I'm going to use Porter stemmer. You can also use any other stemmer such as Lancaster stemmer or Snowball stemmer or even lemmatization instead of stemming. The Python codes to perform these are there in my tutorial videos. So now let's perform stemming. I'm defining a function here as well. Now let's apply stemming to the process data. Now let's apply the word count to see the change in the number of words. And as we can see, the number of words have reduced after applying pre-processing. Now let's visualize the positive and negative reviews using the word cloud. So let's first separate the positive and negative reviews, starting with the positive reviews. Now let's use the word cloud to visualize the positive reviews. Next, let's visualize the most frequent words in the positive reviews. For this, I'm going to use a counter. So let's import the counter. Now let's count the different words in the positive reviews. Now let's put it in a data frame. Now let's visualize the data using a bar chart. Now we have a visual representation of the word count of the different words in the positive reviews. You can make it more colorful by adding colors to the different words. Now similarly, let's do it with the negative reviews as well. So first let's separate the negative reviews. Now let's use a word cloud to visualize the negative reviews. Now let's count the words in the negative reviews. And then let's convert it into a data frame. Now let's plot the most frequent negative words. Now that we have processed the data, let's split the data into X and Y. As we are creating a sentiment analysis model, our X data will contain the verified reviews of the users and the Y data will contain the feedback of the users in terms of the sentiment polarity. Now that we have split the data, let's factorize the data before moving on to model building. So here I'll be using TF-IDF factorizer to factorize the data. So let's load the TF-IDF factorizer and fit transform the data. Now let's split the data into training and testing set with a test size of 30%. Now let's print the size of the training and testing data. Now let's create a machine learning model. To do this, let's import the required libraries. We are importing Logistic Regression classifier to perform logistic regression. Then we are importing multinomial naive-based classifier to perform the naive-based classification. Then we are importing linear SVC to use the support vector classifier. And then we are importing the various matrices to measure the model performance. Finally, we are importing warnings to ignore any warnings that might occur. So first, let's train the data on the logistic regression model. So here we are loading the logistic regression model, and then we are fitting the X-train and Y-train in the logistic regression model, and then we are predicting the value for the given test data, and then we are calculating the accuracy, and then we are printing the accuracy. So for the logistic regression model, we are getting a test accuracy of 89%. Now let's print the confusion matrix and the classification report. Now similarly, let's train the data on a multinomial naive-bayes model. So here we are loading the naive-bayes model, and then we are fitting the X-train and Y-train of the naive-bayes model. Then we are predicting the values, and then we are calculating the accuracy and printing the accuracy. So for the naive-bayes model, we have an accuracy of 86.44. Now let's print the confusion matrix in the classification report as before. Now similarly, let's train the data on a support vector classifier model. So the support vector classifier model gives an accuracy of 89.22. Now let's print the confusion matrix in the classification report. So by comparing the three models, we can see that the support vector classifier model gives the best accuracy. But can we further improve the model performance of the SVC model? Let's find out by performing hyperparameter tuning on the SVC model. So I am importing grid search CV to loop through the different parameters. And then let's define a parameter range. And then let's fit the model for grid search. Now let's print the best cross validation and best parameter. Now that we have the best parameters, let's apply this to our SVC model. And let's run it. As we can see, we have a slight increase in the model accuracy. To make it easier for you to compare, I'll put all the model accuracies on the screen. That brings us to the end of this video. Hope you got an idea of implementing a machine learning model on the IMDB dataset. Don't forget to leave a like and subscribe to this channel if you found this video useful. Thanks for watching and see you in the next video.